Dear researchers, I am Ameen, PhD scholar in Department of Plant Sciences, ICAZ-2022, Islamabad. The topic of my presentation is livestock poisoning neem seed oil, prospective feedstock for eco-friendly biodiesel production. First of all, introduction. Due to rapid depletion of finite fuel resources, the exploitation of renewable energy such as biodiesel has become indispensable. More than 95% of biodiesel is produced from edible oil. However, due to its competition with the food supply, the non-edible feedstock is preferred. Let me discuss what is biodiesel. Biodiesel is basically defined as monoalkyl esters of long-chain fatty acids, and it is considered as petroleum diesel replacement fuel. Biodiesel is biodegradable, sustainable, renewable, non-toxic with little or no sulfur oil content. Biodiesel feedstock. Biodiesel is basically produced from animal fat, edible or vegetable oil, non-edible oil, and different resources, for example, algae, fungi, bacteria, and waste cooking oil. Biodiesel feedstock across the globe. Biodiesel is mainly produced from rapeseed oil 84%, sunflower oil 13%, palm oil or soybean oil 1%, and other resources 2%. Now move towards neem seed oil. Neem seed or neem is botanically known as Azadirachta indica that belongs to family Meliaceae. It yields 40 to 50 kilogram fruits per plant each year. Neem seed oil has 69.4% unsaturated fatty acids, whereas 29.3% saturated fatty acids. Then material and methods. The titanium oxide catalyst was produced by co-precipitation method. The sample was oven dried and then calcined in the muffle furnace at 500 degrees Celsius for 3 hours simultaneously. The oil content was determined by using Soxhlet apparatus, and then FFA content was also determined in the neem seed oil. The biodiesel was produced via two-step methods. First was esterification and the other one was transesterification. And the two-step biodiesel synthesis process was followed in order to reduce the high FFA content of the neem seed oil. And as the result of this transesterification, fatty acid methyl esters were produced. The biodiesel that was impure, it was water washed and then it was purified. Then results and discussion. The highest biodiesel yield was achieved at 1:6 oil to methanol molar ratio, 0.1% of the catalyst loading, 60 degrees Celsius reaction temperature, and 3 hours of reaction time. FTIR analysis was performed and it confirmed that the methyl esters in the biodiesel have been achieved. GCMS of neem seed oil depicted that the occurrence of 14 different fatty acid methyl esters. Fuel properties were found in full accordance with the ASTM, that is International Standard. The flash point was found as 91 degrees Celsius. The pour point was minus 13 degrees Celsius and the cloud point was minus 10 degrees Celsius. Here we can see that the sulfur content is too much low or negligible, that is 0.00431 weight percent, and this is the reason that the biodiesel is renewable and non-toxic, and it is eco-friendly as well because it has too less or negligible amount of the sulfur in it. The total acid number was also found, and it was also very. Then we move toward conclusion. The highest proportion of the biodiesel, that is 95%, was achieved using 1:6 oil to methanol molar ratio, 0.1% titanium oxide. Reaction temperature was 60 degrees Celsius and 3 hours of the reaction time. FTIR and GCMS confirmed the existence of methoxyester carbonyl group. Then fuel properties were found in full agreement with the ASTM standards. Neem seeds, being poisonous to the livestock, can be best feedstock for the biodiesel production. Then future recommendations, it is recommended that effect of phytonanocatalyst can be checked. The studies can be conducted in order to find out the efficiency of biodiesel with different blends by using phytonanocatalyst, and steps must be taken in order to improve the quality of the biodiesel. Neem seed oil cake can be processed or detoxified to be used as animal feed. Thank you very much for your kind attention.